Very good morning. Today we are going to see about the depreciation. Depreciation, like two types of depreciation is there: physical depreciation and functional depreciation. So physical depreciation. This includes wear and tear loss of the equipment, such as corrosion, aging of metals, and insulation, which reduces the cost of the equipment. Like in a hydropower plant, you say you can tell like wear and tear losses in the generator shaft, even same in thermal power station also wear and tear losses will be there. And if you take like a thermal power station, corrosion in the boilers and corrosion in the transmission lines and aging of elements like metals, steam carrying tubes will be there. So that also will due to the aging, it will become rust, and sometimes it will become holes and all. So that we need to replace. Then insulation in the transformers, like insulators in the transformers, then insulation in the transformers, then the some installation in the equipment also will get failure. Some on-load tap changing transformer feeder, some installation will be there, that also will becomes failure. So which this reduces the cost of the equipment. If they buy the cost of the transformer for 1 lakh, 1 lakh distribution transformer, cost of the distribution transformer is 1 lakh, 11 kV bar, 415 volts is 1 lakh. So after 1 year, so due to this aging of the insulation inside that, so windings in that, it will reduce the lifetime. It will reduce the lifetime of the equipment. And also if we are going for sailing after 1 year, the same 1 lakh you can't able to give some like a depreciation charges, they will reduce. Even if I am buying a two wheeler for 80,000 rupees or 1 lakh rupees, I am buying a two wheeler, new two wheeler. After 1 year, after using, I'm just selling that two wheeler. So same 1 lakh will not go. That same two wheeler I can't able to sell for same 1 lakh. Maybe that for 1 lakh, the wear and tear losses for tires will be there. Then engine will be run for some 20,000 kilometers, 30,000 kilometers. I just run that engine. So with that, all the wear and tear losses we have to minus. So only that vehicle will go for only 70,000, 60,000, like that. Depends on the condition, wear and tear losses. If the tire condition, then the engine condition is good, then it will go for little bit higher cost. Like that, same like that. In the substation also, many depreciation also there. Physical depreciation is there. Then, as I said, boilers due to the scale formulation, we have to go for frequent maintenance, sometimes replacement also. So that also depreciation is there. Next is functional depreciation. What is functional depreciation? Due to the changes in technical advancements, the equipment may declared as out of date. Out of date in the sense, latest meters, some energy meters will be there. Previously, if you take like in substation, some old energy meters will be there, ammeters, voltmeters will be there, analog meters will be there. So that meters and all will not give you, even though it will give the accuracy. So it will change in point 0.8, point 0.9, like that. So accurate changes, if you go for now, you have to go for the digital meters. You have to go for digital meters, like the power factor and all. It will showing like 0.98, 0.92, 0.88, 0.98, like that. Accurately it will be showing, whereas in the previous analog meters, that will be rounded off. You can able to detect like only zero point 0.9 or zero point 0.8. If it is in between, then 0.95, like that. But due to the technological advancement, digital meters, you can go for the accurate meters. So in that meanwhile, due to the technological advancement, you need to the old analog meters. So simply like that, that also some depreciation cost will be there, some out of date. In this technology, the old analog meters are out of date. So we have to go for this functional depreciation cost, and also depends on the environmental condition. Environmental condition, like if your substation or your generating station is located near to the seas or oceans, definitely some salty breeze will be coming from the that particular area, that will easily transmission lines, insulators, buses, and as well as your equipments also will get easily damaged. Then, like if your same substation is located in the like in the deserts, the deserts. So due to the heavy heat sometimes your insulation also will be get failure, and sometimes your some equipments may misbehave in the like substation. And due to the in deserts, that the small particles dust will always fall onto the equipment. So by air itself it will come. Even though if you close all the things, some in the some holes it will come, and it will form. It will dump on the that equipments and all. Sometimes due to that insulation failure may happen, short circuit may happen. Like if you go for cold countries, cold regions, cold countries, there also in transmission lines. There might be of like ice formation might be there, so that ice formation will not will be acting as a short circuit between the two lines. So ice formation between these two transmission lines will be there, so that will be shorting. And also sometimes in cold countries, some cool breeze will be there, always cool breeze will be there. So that will happen, that what will happen is that will makes the your transmission lines, every lines to swing up and down. So that swing also will touch the particular line, and also chances of going for short circuit. And sometimes ice formation from your transmission line to the ground. So the ice formation from your transmission lines to the ground, that will cause the line to ground fault. Like that. You can't able to this depreciation and all you need to replace. So in the but by the time some frequent like a line cuts, like it will be break, the transmission wires may be break, and even someone has to replace that. And insulation failure, some due to IC formation, insulation failure may happen. So insulators you need to replace that. So this and all called functional depreciation. How to calculate this total depreciation means this capital cost minus salvage value. Capital cost minus salvage value. That is the total depreciation cost. So total capital outlay is 1 lakh means salvage value may be of 10,000 or 20,000. The salvage may be value might be there. So 1 lakh minus 20,000 means 80,000. So the depreciation, total depreciation cost, we need to raise them yearly wise, maybe yearly wise or 5 years once. It depends on the equipment, life of the equipment. They will be giving the warranty, no, for that equipment. It depends on the life of equipment. We need to save that particular amount, for replacing the equipment or going for operation and maintenance. We need to save that depreciation cost. So it is estimated that useful life of the equipment is L years. L years. The requirement of scheme to accumulate this depreciation fund. Uh, at first one is at the end of the Lth year, it must be secured that sum of C minus V, that as initial loan, can be paid back. So at the end of the Lth year, it must be secured that sum of C minus V. that initial loan can be paid back. So some initial loan can be paid back. Is it must be follow some uniform, consistent year. So some consistent year, 10 years, 15 years, 20 years. So many of the countries are getting the like loan from the World Bank. Even some state government has direct power to get the loan from the World Bank. State government has you can get directly get the loan from the World Bank for your infrastructure development, for constructing roads, bridges, then for constructing the power plants, for constructing new hydropower plants, thermal power plants, everything. Infrastructure development only. So maybe some government schemes also they are giving, and it must be of some consistent year. So this method suggested to save the funds. Funds. First method is straight line method. Next is sinking fund method. So these are the methods used for calculating the save the funds. First is straight line method. Straight line method. So like these are the notations in which we have to learn. So C is nothing but capital outlay. B is nothing but salvage value. R is nothing but rate of interest. L is nothing but life of the equipment. R represents the fixed installment of the loan repayment. Capital R represents the fixed installment. Small r represents the rate of the interest. In this method, depreciation occurs uniformly every year according to the straight line law. The loan paid off in the equal amounts. The loan paid off in the equal amounts. Interest being paid off at the same time, paid on the value of the loan still the outstanding. Okay, so interest also we have to pay still the outstanding as period of the time, and also loan also will be paid in the equal amount 10 years. So you are buying 100 crores means 10 years, 20 years you need to give like 20 crores, 30 crores frequently, and you have to repay that loan amount with the same interest. So interest also per month you are paying one crore, 2 crore, like that you are paying for the interest. So at the meanwhile, 10 after 10 years or 20 years, you can easily pay that whole amount, repay the whole amount. So here, constant repayment, constant sum of the constant repayment plus interest, that is equal to the almost the full amount of the loan. Constant repayment plus interest. Constant repayment. Suppose you are buying 1 lakh. 1 lakh would be for a like a loan. So constant repayment 10,000 you need to pay every year. Sorry, every month 10,000 you need to pay. Interest is some 8%. So 8% interest for 1 lakh, in the sense around yeah, 800 rupees you need to pay for the like a frequent month, for the every month. So 12 months you need to repay that particular amount, you have to pay them. So depreciation okay, matches with the service obtained from the assets. So depreciation value that matches with the service obtained from the assets. So it should not be, it should be fair. Depreciation amount what it should be matches with the service obtained from that assets. Okay, so simply like that, if you are not using any vehicle, not using any equipment, simply like that, if you are going for depreciation also, that will be loss for us. If you are buying a generator and you are not using for 2 years, and again after 2 years you have to maintain and you have to run, so again you need to spend around some cost to go that particular to make that particular generator in the service. So again, for that and all depreciation amount we can't raise. So it should be as whatever the service it is, even it is running for 8 hours, 10 hours, 12 hours, then you can raise this fund and you will keep it this fund for the yearly once or monthly once. You can do that. You can replace that parts with that depreciation amount. So according to this straight line method, For the first year, R, capital R. What is capital R? Fixed installment of the loan payment. So fixed installment of the loan payment is equal to capital C by L. Capital outlay divided by L is lifetime of the equipment. Say if 10 years plus C into R plus this capital outlay, that is rate of interest. That is rate of interest if salvage value is equal to 0. If salvage value is 0, then capital R, that is this fixed installment of the loan payment every year is equal to capital outlay divided by L plus rate of interest if salvage value is 0. If no salvage value is there, where CR is nothing but C minus R into R. C minus capital R into small r. Capital outlay minus that fixed this one fixed installment of the loan repayment into rate of interest for the second year. Similarly, for the second year, C by L plus 1 minus CR divided by L. Okay, 1 minus CR by L plus C by L. At the end of the Lth year, last year, at the end of the up to last year, so R is equal to C by L plus CR by L. So this is the formula for calculating the this total yeah fixed installment of the total repayment, fixed installment. Okay, this is for Lth year. The total charge in the case of straight line method at the end of the first year, total, this is the total charge in the case of the straight line method at the end of the first year. So it is also included, that is C by L is equal to CR, that is nothing but C by L into 1 plus L into R. 1 plus L into R. Okay, so L is nothing but life of the equipment, R is rate of the interest, C is capital outlay, capital amount. This L is lifetime of the equipment. For the second year also, C by L is equal to CR, that is nothing but C by L into 1 plus LR minus R. LR minus R. So similarly for nth year C by L is equal to CR, that is nothing but C by L into 1 plus LR minus N minus 1 into R. N minus 1th year we are calculating up to N minus 1th year we are calculating, because already we have added first year, so up to N minus 1th year we are calculating. Thus the amount decreases by equal amount of CR by L. So equal amount of this C by L will decreases the this amount. So you need to pay monthly, frequently with respect to the lifetime frequently some amount, that same amount you have to pay with the rate of interest also. When N is equal to L, N is nothing but, yeah, N is nothing but years. When N is equal to number of total years, N is equal to L, then the amount to be paid at the end of the economic lifetime will be C by L into 1 plus R. Okay, so at the last year when N is equal to L, then this is the formula C by L into 1 plus R. This is the formula for the last year, that is whole nth year, that is whole years. So this is the curve. Okay, so which is given, this is the reserved in this axis we have taken as reserve funds credited to the depreciation, reserve fund credited to the depreciation, that is from 0, 10, 100, 50, 60 up to 100 percentage. This is the reserve fund credited to the depreciation. In this axis we have taken as percentage of the lifetime. So reserve fund, with the increase in the lifetime, the reserve fund also will be increasing gradually. Reserve fund also will be increasing the gradually. Okay, so this curve here represents the depreciation with salvage value Then this curve B represent the depreciation with the salvage value B. Okay, so this difference between these two okay values, this two curves is the salvage value B, different actual amount, and what we raise for the fund raise for the depreciation with respect to the lifetime. Next method is sinking fund method. Sinking fund method. This method is annual used in the annual payment. It is the sum of the money raised by setting aside from the time to time annually and investing component interest. Okay, I repeat. This is the sum of the money raised by setting aside from time to time annually. Okay, time to time annually whatever the fund raised, and the investing compound interest. So in this we are going for compound interest, not simple interest. There in the this method we have gone for straight line method. We have gone for this simple rate of interest, like monthly we are paying. That is in our nationalized bank. If you are getting the loan means monthly you have to pay the rate of interest, 8% you have to pay the rate of interest. Gold loan you are getting now, you have to pay the rate of interest. So for 100 rupees 8% like that you have to pay. This is the rate of interest. So if the compound interest is nothing but like in some private financial companies you are getting no compound interest, that is called compound interest. So it will multiply, that interest will multiply. So one month, first month 8% means next month it will multiply, it will multiply to again that the rate of interest is increased to 10%. Again next month 12%, next month 14%, like that. For interest, again interest like that. That is called compound interest. So this is of for annually we are paying. So annually if you are paying, the compound interest is somewhat less. So if you are paying for monthly means, this compound interest will be it will increase the rate of interest like anything. Let S be the annual deposit at the end of the first year, which will have the end of which will have end of L minus 1 year. So compound interest is equal to S into 1 plus R by 100 the whole power L minus 1. I think we already studied in basic mathematics, how to calculate the compound interest. So compound interest is nothing but S annual deposit into 1 plus R divided by 100 whole power L minus 1. So let S be the annual deposit at the end of the first year, which will have at the end of the L minus 1 year. So R is nothing but rate of interest. So if you calculate like this, the compound interest, it will increase like anything. The interest will increase like anything. So even in the simple interest, if you are paying 8% means compound interest, as I said, like it will increase with the number of years or number of days or months, whatever we have taken here. So at the end of second year, so yes is deposit after L minus 2 years. L minus 2 years is nothing but S into 1 plus R by 100 whole power L minus 2. L minus 2. At the end of L minus 1th year, then rupees S is being deposit. That is S into 1 plus R divided by 100. So 1 plus R divided by 100. At the Okay, so at the end of the Lth year, rupees S is deposit. The value of sum deposited will be S plus S into 1 plus R by 100 whole power 1 plus S into 1 plus R by 100 the whole power 2 plus up to S into R plus 1 plus R by 100 whole power L minus 2 plus S into 1 plus R divided by 100 whole power L minus 1. So this will be continues. So if you add like this for 10 years, like that, so whatever the due to this compound interest, whatever like you got, it will be somewhat nearly double the times, you need to pay that. If you are buying 1,000 crores means with the rate of interest, with the number of years, after 10 years or 20 years, you need to give again 2,000 crores. So it will be somewhat doubled. Why? Because of this compound interest. So the geometrical progression with the common ratio as 1 plus r divided by 100, that is the sum C is given by S into 1 plus R divided by 100, the whole power of L minus 1. Okay, the whole divided by 1 plus R divided by 100 into minus 1. Okay, so here after simplifying, you will be getting 100 S divided by R into 1 plus R divided by 100, the whole power L minus 1. Okay, now again, how to calculate the salvage value is the capital outlay. So capital outlay. So what? How to calculate the salvage value in the sense? C like just rearranging this CR divided by 100, 1 divided by, that is here we are taking S over this side and C over this side. So S is equal to, so again we have to invert this, that is C into R divided by 100 in 1 divided by 1 plus R divided by 100 whole power L minus 1. So here, besides the changes due to interest, okay, so that is CR divided by 100. So changes due to interest is CR divided by 100. So that also we are adding over here. So CR divided by 100 plus S. So here CR divided by 100 plus S is equal to CR divided by 100 plus CR divided by 100, this term, whole term, into 1 divided by 1 plus R divided by 100 whole power L minus 1. So thus the total depreciation changes plus the rate, interest at the end of each year. Each year will be CR divided by this term. The total depreciation changes plus the interest at the end of each year. So will be CR divided by 100 into 1 plus 1 divided by 1 plus R divided by 100 whole power L minus 1. This term alone. Okay. This is the total. This is the um, changes due to the interest, that is CR divided by 100. This whole term is the total depreciation charge plus the interest at the end of the each year. Interest at the end of the each year. This also you have to pay. So while coming to this thing, sinking fund method. So depreciation, if you see, like this is the initial cost, this is the lifetime. So while plotting, the depreciation is will be decreasing, and the sinking fund raised will be increasing, increasing. So here sinking fund, we are going for compound interest, so it is increasing like this. So whatever the depreciation that is there, the same depreciation it is, we are rising also. So whatever the depreciation is there, easily we can pay, and we can do that maintenance part and replacement part easily. So that even for the whole lifetime of the 20 years, 20 years, if the generated depreciation is going like this, so same time, the sinking fund also we are rising monthly. Here we are rising year wise. So yearly we are keeping some amount for like for maintenance depreciation amount like that. So sinking fund we are yearly we are giving. So yearly up to 20 years we are giving. So whatever, so yearly some depreciation will be there. So whatever the depreciation amount spent, that is equal to the say, fund raised. So that is the this method. So next, coming to the running cost of the electrical energy. So mainly the running cost comprises of cost of the fuel, operation cost, and as well as the maintenance cost. Coming to the cost of the fuel, cost of the fuel is the very very important running cost. Why? Because as I said, in coal generating units, the cost of the fuel increased like anything. We have to purchase tons and tons of coal. If you take a per kilogram of coal in India, like a pure like lignite coal that is used in the like a thermal generating station, not some lignites you will be finding near to your areas. So that will be useful for you making barbecues and for make putting a dum for biryani. Not that coal. This is the pure lignite coal. This cost is around 12 rupees to 18 rupees per kilogram you buy per kilogram, but what you are getting in nearby your places, I think per kilogram like 40 rupees, 50 rupees you are getting per kilogram of coal. That is of waste. Only it will remains for when only few hours. But this coal and all will used up to for many hours. It will burn for many hours. This is the pure coal. So this cost is 12 to 18 rupees per kilogram. Imagine a 100 megawatt or 1000 megawatt plant will have huge tons and tons of coal, 2000 tons, 2500 tons of coals. So, like 2,500 tons of coals is being used for generating the power at particular power plants in megawatt. So again, simply like that, we are using that coal multiple times to extract all the heat. Even though we are extracting like that, but even though cost of the fuel here increase like anything. Whereas if you take like hydropower station, the cost is less, and even nuclear power station also, the cost is somewhat less. So and next, if you coming to the diesel generating units. So diesel generating units, what is the rate of today diesel in India? It is around 90 rupees. So there is no difference between diesel and petrol. Only 5 rupees, 4 rupees difference only. 4 rupees 50 paise difference only it is there between petrol and diesel. Even though we are spending 90 rupees for generating the power for that diesel. So we have to purchase barrels and barrels of diesel, barrels of diesel for running the generator 2 hours, 3 hours like that. Because if you go to the industries or if you go to the generating station for generating 10 megawatt, 20 megawatt itself will take barrels and barrels of diesel. That will be the take the cost of the fuel like anything. Instead of running that, you can simply stop the generation and because fuel also will be saved like diesel from the diesel. Some while extracting natural gases from that also you will get some oils, crude oil. From that crude oil you can generate from that crude oil, waste oils. From that you can generate that. That is of even though that is of some cost, but when compared to diesel, that might be of lesser. But even you have to design the engines in that way because that crude oil has to burn no in that engine. So you have to design that kind of engine. So that kind of engine is very very costly. You need to go for refining that crude oil, some 3 stages, 4 stages again. Then if you take all these things, it might be approximately equals to your petrol cost. Maybe 5 rupees, 10 rupees might be decreasing, but it most probably approximately. But the government only imposing tax for that, but in while extracting itself, if you buy, it will come around the only 30 rupees, 35 rupees with the profit. I'm telling. So normally 35 rupees to 40 rupees you can buy. If you are buying in large scale, you can buy it for even 30 rupees, 25 rupees also per liter of diesel. Then you can run, but not for very long hours, only for some reserves you can use for. So the larger the energy generator, higher the fuel cost. So if you increase the megawatt rating of the generator, then you need to spend more cost on the fuel. For more efficient plant, the increase in fuel cost with the increase in the energy generated. When diesel cost is high, where the coal is somewhat less than the diesel, somewhat less than the diesel. But here the efficiency of the diesel is will be increasing. Here the efficiency of the coal thermal power plant is only 30 percentage. Here the diesel efficiency is around 70 to 80 percentage. But even though the cost of the fuel is high for the diesel, the cost of the fuel also depends upon the interconnection of the system. With the modern optimization techniques, it is possible to generate more power economically. So as I said, we have seen the economic load dispatch. So we have to optimally generate. So today's load based on the today's demand and based on the resources what we are having, we have to we have to go for only least cost generators. Otherwise the cost will goes like anything that will reflect on the tariff. We have to pay like 20 rupees per unit itself. So our power bill will goes like five times, four times, five times. Even if you are paying 1,000 rupees, you need to pay 4,000 rupees per month. 4,000 rupees per month means it is a very, very huge cost for electricity. So that also you should taken care of by using the modern optimization techniques. You have to optimize you have to choose most economically power generating units for the operation of the plant. Next, second one is operation cost. Operation cost. This cost includes the operation cost of the plant in terms of salaries of the labor and technical staff. Salaries of the labor and technical staff is very, very huge amount is being spent on the salaries for labor and technical staff itself. Because in if you take like a hydropower station, only 20 to 30 members only working as a whole. If you take only 20 members only will be working in a shift. If you take thermal power station, it might be like 300 employees up to 500 employees and all. They are running with the thermal power station because for 500 employees, work is there. Work is there means that much equipments are there, that much plants are there. Coal handling plant, ash handling plant, then economizer, boiler, furnace, then steam the tubes. So someone has to maintain the tubes, then generator, then turbines. Like many things are there in the thermal power station. So next after that ash handling plant, then water treatment plant, like that if you take. So even sometimes if you start the boiler and frequently you have to maintain, you have to note down the readings of the boiler, what is the temperature maintaining in that, what is the pressure maintaining from the superheater steam, like that. Meanwhile, but for starting itself it needs 200 employees for one unit itself. So that's why if you take like thermal power station, they will not if they will be having like 500 megawatt generator, a 1,000 megawatt generator, again 500, then 1,000, like that. So if you want to generate 1,500 megawatt, so what they will do is first they will start a 1,000 megawatt. First they will start 1,000 megawatt morning. If you want from morning 9 o'clock to 12 o'clock, for 2,500 megawatt, like that. They will start their process before 7:30 itself. 7:30 itself if they start only. Meanwhile at the 9 o'clock, that power generating will be generated power. They will be generating the power, and that will given to the that particular grid or bus. So they will start 1 hour, 1.5 hours before itself. So first they will start first generating unit, 1,000 megawatt generating unit. So after starting for some times, then the whole few staffs will be there. So majority of the staff will go to another second unit, and they will start second generating unit. Why? Because if you want to operate two generating units, you need to take two times of the employees. That is, uh, once again, 300 employees are going inside. Again, you need to call another 300 employees. So 300 plus 300, 600 employees. Minimum salary 40,000, 50,000. You need to pay 40,000. You need to pay now. So it will go again. This is it will go in some crores and crores of rupees. So and also labors you need to pay, technical staffs you need to pay more, engineers you need to pay more. So labors like 40,000, engineers you need to pay 80,000, 70,000 like that. So you need to pay more, double the times. So TA, DA, allowances, then their insurance, something, many things are there. So everything you need to give them back. So that is that operation cost is very very high, and also this coming to the maintenance cost for particular units, cost is independent of the energy produced for the operation cost. Next, coming to the maintenance cost for the proper operation of the plant. For the proper operation of the plant, some preventive maintenance will be maintaining. Scheduled maintenance is there. Post maintenance are required. So preventive maintenance means if this will not be happen like that. Some for preventive we are adding some other like equipments and some other preventive measures we are, and also maintenance also we are going for. So, like boilers, what they'll do is in non-operating time, they will clean the boilers even once in a day also. Once in a day also, they will go inside and they will clean the boilers. Why? Because the formation of the scales inside the boilers will not give that much steam pressure. Steam pressure will be reducing, and even if steam pressure in the is reducing, the whole total efficiency of the plant will be reducing. So we are spending so much amount for coal. Again, we are spending that much amount and we are not operating the plant means definitely that is the loss for the generation companies. So some preventive maintenance should be there, and even runner turbines and all we have to maintain under scheduled maintenance. Scheduled maintenance means they will in televisions also sometimes they may tell like say today this power plant will not operate because of the scheduled maintenance. They are going for 1 day scheduled maintenance. Whole plant they will maintain. Whole plant from even from coal handling plant to last like generators, and as well as water treatment plant, then as well as your ash handling plant. From all the machineries, all the things they will go for the maintenance. So that is called scheduled maintenance. Scheduled maintenance. 1 day, 2 days it will take for whole thermal power plant. The whole three shifts, if they work, means it will take 2 days, whole 2 days, or maybe a week also. 5 days, 4 days, maybe a week also it may happen. Next, for thermal power plants, I'm telling. For a hydro, 1 day itself enough. Just a runner only. Already maintained, like already maintained runner will be there, turbine will be there. Just like that, they will replace that runner, or they will go for the shaft greasing, then like checking the like calibrating the equipments like that, calibrating the meters, like that also they can go for. Next is forced maintenance. So due to the some fault happening, due to the fire accidents, or suddenly fire accident is happening in the thermal power plant. So suddenly what they will do is they will go for forced stop, the forced shutdown. So forced shutdown, the whole total 1500 megawatt will not get from that particular power plant. So they will go for the forced maintenance. They even though that is that is correct or not, they will go for, even though that is working or not, they will go for the maintenance. They will go for the maintenance inside the boiler. They will go for the maintenance inside the furnace. Then like steel tubes, they will go for the maintenance. Then generators, they will go for the force, even though it is working or not, that is they will go for the maintenance. Yeah, then only the efficiency will be increased. Even daily ones, the alternators shafts, they will put grease before running. They will put grease, everything that is grease might be of sometimes oil flow thing will be there. That You need to replace the oils. Okay, instead of grease, they will go for oil flowed, that is closed shaft, that and all that. So for this, technical staffs and the laborers are to be employed. So for the maintenance also, some in a generating station, some workers may be only for the maintenance purpose only. They will not come for generation side. Only daily once. Then the three shifts they are working. No, so in one shift they will go for the maintenance. They will and in that in the one shift they will run some other generating unit. They will some other generating units they will. So that maintenance is there, and the salaries of that staff and the employees also have to be given, and also that the maintenance cost of the plant also to be given from that fund, given from that fund. Maintenance cost also we should, some replacements also will be there. Sometimes you have to maintain. You need to go for small maintenance thing. That also some cost you need to spend. So that is called the maintenance cost. So with this, the running cost is completed.